Good morning, and welcome back to Dr. Logic Awkwardly Does Logic, except cozily this time with a cat and a comfortable blanket on the couch. I would like to spend a little bit of time taking stock of where we are, what we've been doing, and where we're going to go from here. We have a proof system that allows us to derive valid moods on the basis of the four perfect axioms that we introduced: Barbara, Chalorant, Dari, and Ferriot. Now, earlier we said there are 256 different syllogistic moods. So given the four figures, the four copulas, the fact that we can arrange them into the two premises and one conclusion in different orders, the resulting combinatorics leads us to 256. Now, 4 of those are the perfect syllogisms. There are another 20 that we have identified as being valid, and these 20 can be derived in our proof system from the 4 axioms. But that leaves us with 232 other moods which can't be proved in our system and are invalid. What we would like to be able to do is talk about these invalid moods in a systematic way so that we don't have to kind of go through them one by one individually to show that each one is not provable in our system. Of course we could. If you really enjoy the quiet tedium of constructing counterexamples, you're more than welcome to go through these 256 moods one by one, come up with an exhaustive list of reasons why they are invalid. But we like systematicity as logicians. And so I want to talk to you about the ways in which we can be systematic in showing that these invalid syllogisms are not provable in the syllogistic system that we've introduced. So there's actually 2 components that we want to do. So this is just going to be a short little video as I introduce what we're going to be doing in the next little bit. On the one hand, we want to show that the proof system that we have is a good one, that we are actually tracking validity and truth preservation with the axioms we've identified and the rules that we have. So the bookkeeping rules, the transformation rules, and the hypothetical method. So that will be probably what we'll look at next. How can we show that the proof rule, the proof systems that we have been adequately defined to track our notion of good syllogism? The other thing that we will then do is systematically show that with our proof system, we cannot prove any of the other syllogisms, and that any syllogism that we are not able to prove, we can construct an interpretation for to show that it is invalid, so that it is a bad syllogism. So there's these 2 parts. We want to first show that everything that we can prove is good, and then we also want to show that we can't prove that everything that's bad is something that we cannot prove. So both of these results are somewhat different from the sort of things that we've been talking about with developing proofs in the proof system. So I introduced some videos ago, but I'll give you a brief reminder of it. This notion of the distinction between the object language and the meta language. The object language is the symbols, the terms, the interpretations, the proof rules, all of these things that we've discussed. They've been our object of study for the last couple of videos. The meta language is the language that we use to talk about this proof system or this system of interpretations or this logical language. The meta level is the level that we'll be working at when we try to show things about these proof systems, relating the proof system to the semantics and vice versa. So it's a higher level of abstraction and therefore a slightly higher level of generality, because if I'm going to try to prove something at the level of proofs, I have to give an individual proof for each thing I want to prove. With the meta level results, what we will be able to do is we will be able to show generally. I can give an argument that shows, for instance, all occurrences of simple conversion are going to be good occurrences of simple conversion. They will be truth preserving. Also, I will be able to show that all syllogisms of a particular type cannot be proven in the proof system. And I don't have to do it in a one-by-one, case-by-case basis as we do with showing that something can be proven, where I have to, the way to show that is to actually give you the proof. So the reason that we look at not only object language proofs, but also meta language proofs is so that we can do things in a systematic and generalized fashion. Now, it's really hard to introduce some of these notions without actually going on to give you examples. You might still be thinking, like, I don't really understand what this distinction is. Why is it important? What counts as meta level? What counts as object level? But I also can't go in and start proving the meta language results or the meta level results until you have an idea of what this distinction is, because the problem is the word proof in this logical context is being used to do double duty. So we use it to indicate the notion of a proof within an object language according to our particular proof system. I gave a specific definition. It's this list of formulas. They are numbered. They're all annotated by a proof rule. And so this is how I defined proof to you. And yet I am going to talk about proving results about the proof system. And what we will be using there is not these kind of strings of symbols and detailed predefined rules. I'm going to be giving you an argument that's in English, but it's going to refer back to the definitions that we've introduced, basically to show that the definitions we've defined are the right ones. They do what we need them to do. So that's what we're doing when we're doing meta language proofs. So in the next videos, I will start with proving to you that the proof theory that we've introduced is sound with respect to the semantics. What this means is that if we start off with true premises, our proof theory will never derive anything false. And therefore, every syllogism that we can derive in this proof theory will be a good syllogism. It will be valid under the definition of truth preservation that I gave a couple of videos ago. So that's what you've got to look forward to. Hope to see you in a bit. Cheers.